this is Mr. Potter. In our discussion so far, we've been doing a lot of work with array lists. But one of the issues that we have with array lists is that we really don't have access to the array that's inside the array list. And because we don't have direct access to that array, that makes a lot of the things we've talked about so far, like sorting and searching for data, difficult to work with. And so what happens is not only do we have java.util.ArrayList as something that we can import, but there's also a set of static methods that we can use. And they're in the java.util.collections class. And so what we're going to do today is we're going to talk about some of the static methods that we have access to. Now, of course, these are static methods, so I need to do the class.method name. And all of these end up taking the array list as a parameter. So we're going to be given this array list as a parameter, and we're going to go ahead and do this. I'm going to create two array lists real quick. So I'm going to say array list of type integer, and I'm going to call this nums. Is going to get a new array list of type integer, and then I'm going to do the same thing but I'm going to call this one vowels. And then I'm going to do, like I did last time, I'm going to create an array literal. So I'm going to say integer array, which I'll call digits being equal to, and I'm going to use the array literals. So we're going to do 2.718228284559 4 5 2 3 and 5. So basically the digits for Euler's number. Let me just make it look a little prettier. And what I'm going to do is I'm going to set up a real quick loop just to kind of put these in the array list. I'm going to use the for each loop because we can use for each loops for arrays just like we do for array lists. So I can say for integer I in digits, and we can just say we're going to do nums dot add I and vowels dot add I. And for some reason I've got an extra closed brace from when I created the array literal. So now I've got two array lists, one called nums and one called vowels, and they all contain the digits of E. So if I do system dot out dot print line nums and system dot out dot print line vowels, then I should have a nice little array, and I can see both these array lists contain those digits of Euler's number that we were talking about. So I'm going to keep one of these kind of to stay the same because I want to talk about what's happening here. I'm going to, the first static method that I want to talk about are min and max, because I can go through these and find the biggest digit and the smallest digit in here. Now, if this was an array list of strings like we were dealing with last time, then it's going to find the word that comes first in lexicographical order. In other words, it's in dictionary order. And we do have to be careful with that because characters with capital letters occupy the spaces in Unicode between 65 and 91, and the lowercase letters are going to start at 96. So the lowercase letters actually come after the capital letters, and that's something that's a little bit unnerving the first couple of times you see that, but you get used to it. But if I do system.out.println and I want to print out the smallest digit is plus, and then I just call on the static method collections dot min, passing my list, which is nums. And similarly, I can do system.out.println the largest digit is, and pass it collections dot max nums. So the idea here is that collections.min and collections.max will find the smallest and the largest object in our array list. Now, these objects have to be sortable. So, in other words, they would have to do something that they're comparable. The compare to method would work to. And they do have to be objects, so I can't just use straight less than or greater than, and that doesn't work. Remember that we're using the wrapper class integer. We're not using ints here, and these are array lists of integer objects, not of int primitives. But the collections class offers a real quick way. If I have a list of something, I can find the minimum or the maximum in that list. Continuing on this vein, there's a couple of other things I can do. I can take nums and I can manipulate it in some way. So what I'm going to do here is I'm going going to do I'm going to say collections dot reverse nums, and so if I system dot out dot print line nums now, I'm going to see that those digits in nums have been reversed. So notice that we started with the 2 and ended with the 5. Now here's our 2.7182818 ending with the 5. So the reverse method in collections takes an array list and basically reverses the order of it. And we can also do other manipulations of this. I can do collections dot shuffle nums, and now if I system dot out dot print line nums, what I'll find out is now it's not in forward order, it's not in reverse order, it's actually in a completely random order. So notice that I know I had 1 0 in my list, and there is 1 0 in my list. I had a couple of ones. There's one right here. There's another one right here at the end of my list. All the digits are there. They've just been shuffled. And so if I wanted to pretend that I was writing a program for a card game or something like that, this would be a wonderful tool to be able to shuffle a deck of cards. And later on this year, we're going to talk about the 11s lab, which is one of the labs where we actually do manipulate a full deck of cards. And this collections dot shuffle is one of the ways that we can shuffle quite effectively rather than having to write our own shuffle method. Remember, the whole purpose of using these static methods in the collection class is to allow us to use these methods so that we don't have to reinvent the wheel every time. So what we're going to do is we're going to continue manipulating these. All of these methods just take the list as a parameter. So min, max, reverse, and shuffle. These all basically, the first two just extract data from it. They don't change the list. These two actually do change the list. My list is different, which is why I created two lists. So let me do something real quick. System dot out dot print line val. Remember, vals was my copy that I had made, and my vals should stay in the same order. And so notice vowels is still in Euler's number order. But I want to do a couple of things with vowels. One of the things I want to do is do collections dot sort on vowels. And rather than reversing the order rather than shuffling the order, this actually performs a sort on the list. So if I go through here and system dot out dot print line vowels, then I'm going to end up with a completely sorted list. So I have 0, then 1, 1, 2, 2, 2, 2, 3, 4, 4, 5, 5, 5, 7, 8, 8, 8, 8, 9. Notice that the number representation that I've had has no 6s in it. And what's really nice about dealing with a sorted list is now I can actually search for a digit. So if I wanted to do system dot out dot print line, and I can say that 4 is in position plus collections dot binary search, and I'm going to pass it the list, which is vowels. That's my sorted list, and along with the thing that I'm looking for, which in this case is a 4. And so when I run this, it should tell me the position in my list where I can find the integer 4. Remember, I'm talking about the integer 4, not just the primitive int 4. This auto wrapping is something that we can deal with. So it tells me that 4 is in position 9. So if I look, there's 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So it did find this, and it did it through the binary search. Notice that I've got 19 numbers in this list that I've got, and half of 19 is 9.5, or 9 if we're dealing with ints. So that was the first position it looked, and that's where it found it. If I do the exact same thing, but search for a different digit, let's say I want to search for a 1, then when I run that, it's going to look at 1 is in position 1. Notice that we start with this middle position, that's position 9. It's not there, so we're going to look at the lower half of the list. I've got 8 digits to look at. Position 4 is halfway. It's not there, so then we're going to do halfway. And I've got basically from positions 0 to 3. Half of 3 is 1, so that's the next position we look at. And there it is. So it ends up using the binary search technique. So if I have repeats, it's not necessarily going to find the first occurrence of it, but we talked last time about how index of would find the first occurrence of it as well. The thing is, binary search works a lot faster than index of. Index of actually goes in order, so it's a linear search, whereas this binary search is much faster. And we'd really see the difference if we were dealing with a large value, a large set of numbers. There's one other thing that I want to try here. I want to do the exact same thing as I did, but I want to search for 6. Remember that I remarked that 6 was nowhere in my list, and this actually does something rather interesting. We notice that when we're supposed to be returned a negative number if there's an error condition. So if I see what happens when I run this, notice it gives me a negative number, but it gives me a negative 14. This is rather peculiar. Remember that we're doing a binary search, so we're going to start at this position 9, and 6 is bigger than 4, so we're going to look at the top half of the list. So from 10 to 19, so 10 plus 19 divided by 2 is 14. It's going to look at position 14, and no, it doesn't find it. It's going to keep going, but what it actually does is it tells me not only that it's negative because it's not where it's supposed to be, but it tells me where it should happen. It should be here. And that's what this 14 actually does. It's telling us where it should be and where it would be if it were in the list. It's basically telling us where the error occurred, where it was like, nope, couldn't find it anymore. So that's one of the nice things about binary search, is that if I have a sorted list and something is glaringly missing, then I can find out, not only is it in the list or not, but I could also find out where it would be if it was in the list. The collections class offers static methods that allow us to manipulate and to work with array lists and other data collections. But what's nice about it is that we don't have to know the underlying structure. I mean, I know that there is an array in an array list, but really the collections classes of the collection class methods really don't care about that. All we have is an interface. All we have is a user way to access that data and to manipulate it so it looks in a form that we can use. And that's really the power of this collections class. So once again, this is Mr. Potter. Thank you for watching. Have a great day.